Hi students, welcome to Chemistry online classes. In the previous class, I discussed about the optical isomerism. In that, if you pass the light through a organic compound through a polarimeter, then that light is not rotated, that is optically inactive. Light rotated, it means plane polarized light rotated in any one direction, then it is optically active. Right side direction rotated means what you call dextro, that is denoted by small d or plus. If left side rotated, then what you call that is levo rotatory, or is denoted with the minus or small l. Then optically active. If the compound is optically active, then what is the condition? The compound should contain chirality. Chirality means what is that? Non-superimposable mirror image. Note that. If you want definition, now already you may be learning the haloalkane chapter. There also definition is in your textbook. Chirality means what is that? Non-superimposable mirror image. Now, here in the last class also I discussed the three terms. One is asymmetric carbon, chiral center and stereo center. Three terms are there. So what is the difference between these three statements? One is what is the carbon, then here methyl group, ethyl group, isopropyl group, this is all groups are different or same here. Around this carbon all groups are different. Then this is called asymmetric carbon. Asymmetric means what is that? Symmetric opposite word. Symmetry means what is that? If you pass a plane, it divides into two equal parts. It contains plane of symmetry. If you cut this molecule in any direction, if you are not getting equal parts, then it is asymmetric. Symmetric opposite. It means there is no plane of symmetry. This is called asymmetric molecule. Clear? Now, another one. Same here. Three mean propyl. This is methyl. Same, this is isopropyl. This is called ethyl. How many groups are there? 4. Nitrogen form how many bonds? Generally 3 bonds with one lone pair. That lone pair also involved in the bonding. What do you get here? Positive charge. Clear this is? Next one. This is carbon, double bond, carbon, here hydrogen, here methyl, here hydrogen, here methyl. Now, this is asymmetric carbon. Next one is chiral center. Chiral center generally denoted with the star marks. Okay? And these two are, this is only asymmetric. This is not asymmetric carbon. This is nitrogen. That's why asymmetric carbon. These two are chiral center. This is stereo center, or also known as a stereogenic center. Okay. Based on this, what you concluded? All chiral centers are stereo centers, sir? Yes, sir. No? You are not analyzing here. All stereo centers are which one? Chiral. It means stereo center given for 1, 1, 2, 3. No? All are which one? Stereo centers. But all these are what do you call it? Chiral center, sir? This is not chiral center. Chiral center is up to this 2 only. Asymmetric carbon, this is only. Based on this, what you concluded? All chiral centers are stereo centers, but all stereo centers are not chiral centers. That's the concept. Then you may ask the question, chiral means what is now only told that non-superimposable mirror image. Non-superimposable mirror image. If you draw its mirror image and pick up and place on the first one, in the last class I told you how to check that superimposable, non-superimposable, draw the three-dimensional molecule, draw its mirror image, that take the mirror image and place on its original. If it is exactly arranged, then it is called superimposable. If not, then it is non-superimposable. That is called chiral. Clear this is? So now, this is not chiral. See, I will use another pen. Stereo centers I want to denote it with this dotted line. This is also stereo center. This is also stereo center. This is also stereo center. Stereo center meaning that by exchange of any two groups you will get another isomer. Exchange of any two groups you will get another isomer. Then how you will get another isomer? You see here. CH3 double bond exchanging their position. Then here you will get the CH3. Here you will get the H. Then it is which form? Cis bond. Here which form? Trans form. So here double bond is cis and trans we can tell. Then here how to tell cis and trans? Possible? Here. No. Then if you exchange, this group comes to down, this group comes to here, then you will get another isomer or same? Another isomer you will get. That is how we know that another isomer or not, by using the RS nomenclature. That we will discuss here, RS nomenclature. Either nomenclature already we decided. We know that. So now RS nomenclature also is in stereoisomerism. Based on that we can conclude is this another isomer or not by exchanging the groups. I will show with that in one example. So here which is blue color dotted line is given. They are which one? Stereo centers or stereogenic. Genic means it formed. Stereogenic centers. Well, chiral means what is that? Non-superimposable mirror image. Then these are superimposable. If you draw, this is the first one structure, and it is if you consider it is mirror image to this one. CH3 H is not mirror image. It is not mirror image. If you draw its mirror image, it is superimposable. How? See, CH3 H double bond CH3 H. Pick up and place. Superimposable? Superimposable or not? No. How? This CH3 comes which side? Hydrogen side. Superimposable meaning what is that? Exactly aligned. Aligned exactly? Alignment, arrangement. Left side what is that here? Hydrogen. Here what is that? If you pick up and place on hydrogen CH3 or H? CH3. Then anyone is not, then it is called what is it? Chiral. It is not exactly aligned. But what I told first, it is superimposable. How? In the previous class maybe I told that rotate the molecule in any one direction, left or anti-clockwise or clockwise, and place on the first one. Then it is superimposable. Rotate this, these two hydrogen come this side, these two CH become this side. 180 degree rotate and place on this first one. Exactly superimposable. Then it is not chiral. Chiral means what is it? Non-superimposable mirror image. These two are which one? Look like is non-superimposable, but actually these are superimposable. Then by looking at molecule, immediately we cannot tell it is superimposable or not. So what you have to do? See the molecule if superimposable, okay. Otherwise you have to check, rotate the molecule in any one direction, left or right, clockwise or anti-clockwise, any degree, and check the superimposability. If superimposable, that is achiral. Non-superimposable, that is chiral. Therefore, these are chiral centers. You may be studied already, may be given this information in the conformational isomers. In conformational isomer, two types are there. One is interconvertible. CC single bond rotation interconvertible is there. Another is amine inversion is there. In amine inversion, first form its mirror image is exactly fast interconvertible. Therefore, they are not considered as a chiral. They are just conformers. They are not considered optically active. But here, this amine is which one? Quaternary amine. Quaternary amine. All four groups are different. Then it is chiral. But three groups with one lone pair is there. That time it is fast interconverted into another form. They are conformers. You just check that conformers. Then you will know that. With one lone pair is there, generally it is easily converted to another form. In that one lone pair also some exceptions are there. I will discuss in the amine chapter in the second year. So I am not discussing the complete the nature of this amine. Only four groups are different. Then it is chiral. Like this carbon. Asymmetric carbon this is. Chiral also. All asymmetric carbons are which one? Chiral. Asymmetric meaning what is that? There is no symmetry elements present. What are the symmetry elements? Plane of symmetry absent, center of symmetry is absent. Now we will discuss what is the plane of symmetry. So one plane of symmetry example. POS, plane of symmetry. Plane of symmetry denoted with which letter? Sigma. So now see. In the previous class I may be given this one. This is which one? Methane. Cut this molecule in any direction, you will get the plane. Now I am cutting this molecule like this. This is a plane. A plane pass through the molecule, then it divides the equal parts. Like this I am passing. Then this side H, this hydrogen half, this carbon half, this hydrogen half. Then you are getting equal halves or not? Equal halves is present and they are mirror image to each other. This hydrogen is mirror image to this. This hydrogen mirror image to this one. So they are equal parts and mirror image to each other. Then only it is called plane of symmetry. Plane of symmetry present. Sigma present. Sigma present means chiral or achiral? In the previous class I told that sigma Ci present means what is that? Achiral. Sigma present Ci absent. That is also called which one? Achiral. Sigma absent and Ci present. That is what you call achiral. Sigma absent, Ci absent, and what do you call that is? Chiral. In based on this, what you concluded? Anyone is present? Achiral. Both absent, then it is chiral. Clear? So plane of symmetry present here? Present. How many planes possible for this? In the last class I maybe told you remember or not? How many planes possible? 6 planes are possible. So 6 planes are possible. Now CH3Cl. CH3Cl. Otherwise blindly you can follow one statement. At least any two groups are same. At least any two groups are same, that is achiral. Here how many groups are same? How many same? 3. Here how many same? 4. At least 2 same in what you call that is? Achiral. Note on statement better. Any two groups are same, that is achiral. For this, if you cut same like this only, then it is having which one? Plane of symmetry present or not? H is there, this half, this carbon is half. Sigma is present, then it is achiral. If you take here H, this is called CH2Cl. Cl, H. If you cut like this, then it having plane of symmetry or not? Plane of symmetry present. Then you may ask the question, sir, if I write like this, Cl, H. If I cut like this, can you get the plane of symmetry? If you cut like this, then can you get plane of symmetry? This side Cl, this side H. Cl half, H half, carbon half. Then plane of symmetry present or absent? Absent. Then what you call? Chiral or chiral? Chiral. But already one statement I given. Which one? If any two groups are same, then that is achiral. But here not. Then how to define that? Any two groups are same mean you have to check the plane of symmetry in all direction. Not only one direction. In all directions, if you pass the plane, it do not give two equal parts and do not mirror image to each other, then only it is plane of symmetry absent. If any one direction you pass the plane and it giving two equal parts and mirror image to each other, then it having plane of symmetry. So in this direction already shown that. So plane of symmetry is present. You on board you can't understand. You have to make one model. I don't have model, so I am not showing here. At home you try it. Take the one thermocol sheet and you have to place the sticks and observe and cutting in all directions. Then you can easily observe in which direction having the plane of symmetry. Simply on board whatever I am teaching, that is not easy to understand. You have to try. If I am telling, okay, I will do in your mind, but if you go to home, you are not trying, you will not understand the clear chemistry. Okay? So we know what is the plane of symmetry. Plane of symmetry means in all directions you have to check, not only one direction. Immediately if you see the molecule, it having plane of symmetry, it should be striking your mind. Next one is center of symmetry. CICOS, center of symmetry. Now, this is one molecule. Here Cl, here H, here H, here Cl. Now, this is an imaginary point. This is an imaginary point. Draw a line from any one of the atom or group. Now I am taking this atom. Draw a line from any one of the atom or group. For example, an atom. Drawing from this atom through the center point. Through the center point. If you take the scale, then it will be straight line. Actually, it looks like curved straight line. Okay. Draw a line from any one of the atom or group through center point. Through center point. Extend the same length. Here, if it is 5 centimeters, then next also we have to extend how much? 5 centimeters. Extend the same length. I am extending here. Then, if you get the same atom or group, then it having the plane of symmetry. Sorry, center of symmetry, because it's the center of symmetry. Okay. Now, it is look like one plane diagram. These are two equal halves. Here Cl is there, here Cl is there. If you see in mirror, this will be up here. Okay? Once again I am telling you what is the center of symmetry. Draw a line from an atom or group. Definition not required, just listen here. The atom or group. Pass to the center point, imaginary center point. Extend the same length to the similar atom or group. If it is there, then it having center of symmetry. This is nothing but this divide the two equal halves. They are mirror image to each other. Clear? Then it having center of symmetry. If here H is there, here Cl is there, then it having center of symmetry. Here H, here Cl is there. No, because whatever atom is there or group is there, here also same required and both should be in the same length. Then we are not measuring with the scale in examination. We have to consider both are equal length. Okay. So here which is present? Ci present. Ca present means achiral or chiral? Chiral. Chiral. Achiral. Or see here. Anyone present. Ci present. Achiral. Ca present. Achiral. Both absent. Which one is Ci is absent. Then only it is called chiral. That's why note on this clear. Next, these two are we have to use for problem solving purpose. Another Sn also is there that we are not using in the problem solving. If these are not solved the problem, that time we are using the Sn. But I hope for up to JEE mains purpose, these two are enough. Okay. So now another one. this molecule having center of symmetry or not, or plane of symmetry or not, check. Which molecule having the plane of symmetry, which molecule having the center of symmetry? The first one having which one? If you consider this is a molecule like this, cut CS3, CS3. By looking directly, this molecule look like which one? Having plane of symmetry or not? But no plane of symmetry. But no plane of symmetry absent. That I will show. Here what is there? If you consider this is the imaginary point, and if you draw this line, then it is look like which one? Center of symmetry. Look like center of symmetry, but not. How to imagine this is already this little bit I discussed in geometrical isomerism. When alleles are present, any chiral carbons are there here? Chiral or asymmetric carbon. Asymmetric carbon is what is that? All four groups should be different. This carbon, if you consider, all four are different. If you consider this carbon, HCS is different. But here, carbon double bond is there. Double bond is how to assume 210 carbon. Carbon same or different? Same. Then there is no chiral carbon here. No chiral carbon. But it presents chirality. That property, what do you call? Non-superimposable mirror image. Non-superimposable mirror image, what do you call this is? Chiral center or chirality. Clear? Then how this is? In geometric isomerism already told here. How many double bonds are there? 2. One double bond is horizontal, another double bond is one? Vertical. Got the point? Vertical, if you cut, you will get equal parts. But horizontal, this side, if you take this one, this is vertical if you consider. Then if you horizontal mean, this is vertical. First double bond, vertical. Second double bond, horizontal. In second double bond, what is the front end? CS. Here what is the H. If you cut like this, CS3, H. Here what is there? CS3. Up, down what is there? H. Up, down CS3, up, H can no problem. Then what do you get here? CS3, CS3 or H is equal, here equal. So this part we are getting equal. It means plane of symmetry is the half part, but another half part not plane of symmetry. But overall molecule, no plane of symmetry. Half part plane of symmetry, half part no plane of symmetry. Overall, no plane of symmetry. Other concept? Therefore, do not having any plane of symmetry. Clear? Then this is what you call chirality present or not? Chirality present or not? Chirality means what is it? Non-superimposable mirror image. So if you draw this one, if you consider this vertical, this is CH3, this is H, this is back carbon, this is front carbon, this is CH3, this is H. It's mirror image I am drawing now. Mirror image. Mirror image, this first appear or this will appear first? Last class only I told that if you see like this in mirror, my front part will appear first, not back. So this is the front, this is away. Now for this mirror, then H carbon, CH3, clear? Now pick up this, place on this. Then what do you get? Here vertical, this is vertical, this is which one? Horizontal. Then here what is there? Horizontal. Here what is there? Vertical. Pick up this and place. On vertical what you will get? Horizontal. Superimposable? No. Non-super. Rotate this molecule. If you rotate this molecule, then what you will get? Rotate 180 degree. Then horizontal convert to vertical, vertical convert to horizontal. Again place on this, then reversible. So there is no superimposable. Therefore it is chiral. See in the last class one statement I given, Optically active means what is required? Absence of symmetry element or one chiral center is there, always optically active. Second one, what is there for optically inactive? One, achiral molecule. Some exceptions are there. What are the exceptions? Allenes. This is which one? Allenes. Allenes have any chiral center? Center. Not chiral, but total molecule chiral. Center means one atom type, anyone. This is called chiral center, chiral center. Overall molecule is chirality. It means plane of symmetry, center of symmetry is absent. So overall this molecule is what happened here? Chirality present. Chiral centers are not there, or stereo centers are not there, but it is chiral. Therefore, optically active. Then what is the necessary condition for optical activity? That symmetry element should be absent. Only one chiral carbon is there, that is the necessary condition? No. One chiral carbon is there, that is always optically active. But more than one chiral carbon is there, may not be. Therefore, what is the necessary condition for optical activity? The chirality should be present. Chirality means what is that? Symmetry element should be absent. When they are absent, they are non-superimposable mirror image. Clearly you have to observe the terms, otherwise you will confuse. Okay? Then this one look like center of symmetry, but not. How? One is vertical, another is horizontal. It means this CH3 is in this direction, but this CH3 is up. Got the point? Therefore, one is horizontal, another vertical, means you will not get the center of symmetry. And one point you have to remember, for any molecule, only one center of symmetry will be there, but plane of symmetry many. See, I already told you that for CH4, for Neet, how many plane of symmetries are there? 6. But center of symmetry for any molecule generally 1. If it is present, some molecule may not have center of symmetry. If it having the center of symmetry, how many center of symmetries are possible? Only 1. For this room, how many center of symmetries are possible? Room is cubic. Then only one center or any number of centers are possible? 1. So like this also you know that body center, only one body center possible, many body centers not possible in the solid state. See here I say. Okay, so now we know that one example. Another example, what is I given? See, for optically inactive, achiral molecules are required. Exceptions are allene. Second one, what is that? Biphenyl system. That is called heteroisomerism. Heteroisomerism. But when you are studying this stereoism, always we compare with the geometrical isomerism. In geometrical isomerism, odd number double bond shows the geometrical isomerism, even number not show. Even number shows here optical isomerism. You just compare with that. You check the always geometrical isomerism, optical isomerism. Immediately it should be straight. It's not that much difficult. Only simple statement. Even number double bond, optical isomerism. Odd number double bond, geometrical isomerism. But groups we have to check. Now here even number is there, but also I can show it is optically inactive. How? Now this is optically active or inactive. What I told here, this is vertical, this is horizontal. Vertical mean what is that? Equal is like this hydrogen is here, like this. One is like this. H. If you cut like this H half, this H half. Here what is that? HCl. If you cut this molecule, left side what is that? H. Here CH. Then overall molecule, plane of symmetry present or absent? Look like absent. Because here equal is here not equal. No? Before also that is only I explained. But now I am telling this optically inactive. Optically inactive means what is that? Plane of symmetry present or center of symmetry may be present. Yes or no? Then I will show it is plane of symmetry present. How? In this condition I consider this vertical, this is horizontal. It may be this is horizontal, it is vertical. Possible or not? If you rotate the molecule, then it convert. Vertical to horizontal, horizontal convert to vertical. So in this condition, now reverse, if you take the horizontal, this is vertical. Now this side H, this side